Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be learning about the alternating series error bound. So now we're going to try to find some sums of these series, but we're going to figure out what the error is in the sum if we find just a partial sum. Okay? All right, so let's take a look. So if an alternating series converges, then the series must converge to some value, right? That's what we already know. Okay, so this is an alternating series here. I listed out some terms. I could add that, subtract that, then add that, subtract that. I can do this forever, or as long as I'd want. Okay, but if I were to add, let's say, just the first four terms, that wouldn't give me the whole sum of the series. It would just give me what we call a partial sum, right? Okay, it would give me a partial sum, not the whole thing. All right. So what we're going to do is we're going to use the alternating series error bound to find the maximum error that a partial sum has to the actual sum of the series. So for example, let's say I were to just take 1 minus 1/4. Well, that would be 3/4. Obviously, 3/4 is not the sum of the series because I have 1/9 to add. I have to subtract 1/16. Then I'm going to have to add 1 over 25, right? And then subtract 1 over 36. Okay, we'd be doing this forever. So this is obviously just a partial sum. It's not the actual sum. So the question is, although we can't add these forever and find the actual sum, what we can do is we can figure out how far off we are from the actual value using the alternating series error bound. All right? All right, so let's see. So here's how this works. If a series converges by the alternating series test, so the first thing is the series has to converge. If it doesn't converge, if it diverges, well then forget it, right? it can't have a sum because it diverges. So the series has to converge first. Then the error in using the first n terms to approximate the sum is less than or equal to the n plus first term, meaning the term immediately following the terms used to find the partial sum. Okay, so here's the math behind this, and then we're going to talk about what this all means in just a minute with some numbers. So first things first, S is the sum of the series. S sub n is the partial sum using n terms. So however many you want, okay? Now, if I were to take the actual sum of the series and subtract a partial sum that only used, let's say, 5 terms, okay, if I were to add the 5 terms together, right, and then subtract it from the actual sum of the series, that would give me the error, right? That would tell me how far away I am from the actual sum, okay? The actual sum minus the partial sum would tell me how far off I am from the true answer. I claim, or we claim, that error has to be less than or equal to the next term in the series in absolute value that you did not use in the sum. All right, so let's say I used 5 terms in this sum, this partial sum. Then the error has to be less than or equal to how far off I am using the 6th term. Whatever the 6th term is, that's how far off I am from the true value. Okay? All right, so let's see how this works in practice with some numbers. It'll make a little bit more sense, I think, when you put some numbers to it so that you kind of get an idea. Okay, suppose the first 3 terms were used to sum the series below. All right, here's the series again. Let's say I want to find S sub 3. So that would be 1 minus 1/4 plus 1/9. So let's do that. 36 is the common denominator, I think, right? So 36 is the denominator. 1 turns into 36. 4 turns into 9. And then 9, I need a 4, right? So that's 40. 40 minus 9 is 31. So the sum with the first 3 terms is 31 over 36. Now, is that the actual sum of this series? No, right? That's just the sum of the first three terms. There's, a million more terms to go. Plus 1 over 25, minus 1 over 36, plus 1 over 49, minus 1 over 64, right? I mean, we could do this forever, okay? But the alternating series error bound says that the error in calculation between this partial sum, 31 over 36, and the actual sum has to be less than or equal to the fourth term of the series, the first unused term after the terms you summed. So I summed the first three. So the error has to be less than or equal to the fourth term in absolute value. So the error has to be less than or equal to the absolute value of negative 1 over 16, which is 1 over 16. So now, what does that mean for me? That means that the actual sum of the series, okay, is something, or has to be less than or equal to 31 over 36 plus or minus 1 over 16. So at this point, I'm 1/16 off from the true value of this series. All right? I'm 1/16 off in either direction using the first three terms. If I were to use S sub 2, the first two terms, 1 minus 1/4 is 3/4, then I'd be off by 1/9. So then the actual sum would be 3/4 plus or minus 1/9. Okay? That's how this works. You're going to the first unused term after you find your partial sum to determine what that error would be. All right? So, same idea. So the value of cosine of 1 is given by this set of terms. I want you to find for me S sub 3. Well, S sub 3 would be 1 minus 2 factorial plus 4 factorial. So that would be 1 minus 1/2 plus 1 over, I got to do 4 times 3 times 2. So that's 24. So let's see, make 24 the denominator. So we have 24 over 24 minus 12 over 24 plus 1. So that's 25 minus 12, 13 over 24. So S sub 3, the third partial sum, is 13 over 24. Now, to determine the error bound for this alternating series, well, I added the first three terms, which means that the fourth term in absolute value is the largest that the error can be. So the error bound is 1 over 6 factorial, which is, I don't know, whatever number that is. You can multiply 6 times 5 times 4 times 3 times 2 if you want. But that's what the error is. So the actual sum of this series is 13 over 24 plus or minus 1 over 6 factorial. It's somewhere between there. Okay? It's somewhere in between those two values. All right, I don't know what the sum is. I just know it's in between those. Okay? That's how this error bound works. I'm putting a bound on the error. I'm saying the largest that the error can be is this much. And then I know my sum is somewhere between that number and that number. I don't know what it is, but it's between these two values. Okay? And that's all this error bound works for. Okay? As always, thanks for clicking.